So welcome to 7.7. We're going to plot systems of linear equalities. Just like linear systems of linear equations were more than one equation, this is more than one inequality on the same graph. So let's remind ourselves about linear inequalities. So I have graphed this equation which is got a y-intercept of 0, 3, and a slope of negative 1/3, right? And so that one right there is y, and notice it's shaded above the line, and it's a dashed line. Y is greater than negative 1/3 x plus 3. And we're going to graph y is greater than 1/2 x on the same coordinate plane. Okay, so the y-intercept of that is 0, 0. Right? And the slope is positive 1/2. So that, let's get this out of the way, over 2, up 1, over 2, up 1, over 2, up 1, over 2, up 1. And once again, it's going to be dashed. So I'm going to draw a dashed line right on top of this one. And so 1, 2, 3, here we go, some dashes. And it says y is greater than 1/2 x, so I'm going to shade above, but I'm just going to do this lightly at this point. So notice we have some, right, so we have this area down here which is not shaded at all. We have an area over in this area to the right, which is shaded just with the black. We have an area over here which is shaded just with the new one, the red one. And then we have this key area here, where it's shaded by both inequalities. And this is the solution area for this system of inequalities. The solution to a system of inequalities is where the two shaded areas overlap. So it says outline. So we're going to outline that. I'm going to make it a little, right? And it actually goes on forever up here. We just ended at 10, negative 10. But that is the solution to a system of inequalities. Right? So here I've done it in red and blue, right? So in one line, it's shaded red above one line. Above another line, it's shaded blue. All right, and then this area here, although it's a little tough to tell, is shaded with both, and that's the solution to this system. Okay, so we're going to plot the two. So I'm going to do the first one. Y is greater than 2x minus 4. So 0, negative 4 is our y-intercept. Our slope is positive 2, which is over 1 up 2. Right? Run of 1, rise of 2. It's greater than 2x minus 4, so it's going to be a dashed line. And it's greater than that, so we're going to be shading, and I'm going to just do it lightly, right above there. Do the other one in a different color. Y is greater than or equal to x, so that means it has a y-intercept of 0, 0. Right? And a slope of 1. Coefficient of x is 1. So we're going to go like that. And it's going to be a solid line, because greater than or equal to. And so notice the red area, it wasn't that great on this, the red area spread down there. But what is the solution to this? All right. Well, the solution is where they are both. So where is that? So let's do a little, let's pick a different color here. So that is this area, right? Below the blue is the border here. But when we get over here, the border now becomes the red dashed line, right? And this area in here is our solution. And hopefully you can be neater than me. It's where they're both shaded areas overlap. So let's graph this new one. the top equation has a y-intercept of 0, 4. It has a slope of -3. Slope of -3 is down 3 over 1. So we're going to start at 0, 4. And then we're going to go down 3 and over 1. Down 3 and over 1. Down 3 and over 1. And it's less than -3x plus 4, so we're going to do a dashed line. It's not or equal to. So here's our dashed line. And now it's less than, so we're going to shade the area below it. I'm just going to do that lightly, right, like that. That's the area below the line. It's not left or right. And the bottom one has a y-intercept of 0, 0, and a slope of 2. And so there's 0, 0, and a slope of +2 goes over 1 up 2, over 1 up 2, over 1 up 2. And it's going to be a solid line because it's or equal to. And then the solution is the area, right, where they are both, right? So here's the blue goes this way, right? I'm going to erase all this horrible shading. And so then where they are both shaded will be, I don't want to use red. Let's say I'll use green. Okay, so there's the border, right, of the red, because we're below the red line and we're above the blue line. And so where they are both shaded, the overlap is in this area, and that is the solution to this system. So is -4, 3 a solution to the system? So let's figure that out. -4, +3 is right here, and so that's yes, it's in the shaded area. Is 1/6 a solution to the system? 1/6, right? That's a no, right? This is a yes. It's not in the shaded area either. It's in, now interestingly, it would have been in the blue shaded area, all right? Because this section where that is would have been shaded in blue. Is -1, -2 a solution? -1, -2 is right on the solid line, solid blue line. And that's the edge of this shaded area. So that's a yes. Okay, so if a point is on a solid line, it's a solution. If a point is on a dashed line, it is not a solution. Now, there's another way we could have checked without making the graph whether a point is a solution. So we're going to check whether 2, 6 is a solution. Well, we could make the whole graph and see if 2, 6 is in the shaded area, but there is a faster way if you don't have the graph already, and that's just putting this in here. So let's do that. So x is 2 and y is 6, so we're going to put it in the top one. So 6 is greater than 4 times 2 minus 1. So 6 is greater than 8. 4 times 2 is 8 minus 1 is 6 greater than 7? No, that makes no sense, right? So no. Now, you stop. Once you get a no, that means it wasn't in the shaded area of this one. And if it's not in the shaded area of that one, then it's not in the shaded area of the solution, right? You have to get 2 yeses for it to be a solution, for it to be in the overlapping shaded area. So let's try this one. All right, so here x is 1 and y is 12. So we're putting it in the top one again. 12 is greater than 4 times 1 minus 1. 12 is 4 times 1 is 4. Well, 12 is greater than 3, so it's in the shaded area of the top one. Now we'll put it in the bottom one. So 12 is less than or equal to 3 times 1 plus 7. Well, 12 is less than or equal to 3 times 1 is, this is no, so this one's also no. All right, it has to be 2 yeses to be in the overlapping shaded area to be a solution. Okay, so to remind you, standard form, the one at the bottom is in standard form, ax plus by equals c. And those are a little slower to graph, but we can graph those as well. So let's do this. So we're going to graph the top one, just like when we've been doing. Y-intercept of 0, -7. Slope of -2/5. Now, -2/5 is down 2 over 5. So down 2 over 5. And we'll run out of room, so I'm going to go backwards. Over 5 and up 2. And there's my line. And it's going to be a dashed line. And we're going to shade above that dashed line. Oop, I just made a solid line, so let me fix that. You guys should have an eraser, but me, I have to redo it. Okay, so there's my dashed line, and I'm going to be shading above that line. Now, this bottom one is in standard form. Now, we could rewrite it in slope-intercept, but it's usually faster just to find the intercepts. So to find the y-intercept, you make x equal to 0, and you do this with equal signs. Divide both sides by -3, so y equals -4, so its y-intercept is 0, -4. Then the x-intercept, where y equals 0. Divide both sides by 2, x equals 6, so 6, 0 is the x-intercept. And it's going to be a solid line because there's an or equal symbol right there. So we're making a solid line, and we're going to, right, so the blue, let's do this way. The blue we're shading below. Oh, no, you can't just do that. I almost did a classic mistake. Right, I can't just look at the symbol. This is standard form. I have to see if 0, 0 is a solution to this system. So let's do that. I'm running out of room. So I'm putting 0, 0 into that. So 2 times 0 minus 3 times 0 is less than or equal to 12. So 0 minus 0 is 0. Is 0 less than or equal to? Yes. 0, 0 is a solution. So even though it says less than or equal to, the blue one is getting shaded above. All right? Because 0, 0 is the solution. Right? Now I could have picked any point. I could have picked 10, 10 and put it in there. Just the math would have been a little harder. If 10, 10 is a solution, then you shade the side with 10, 10. If 10, 10 is not a solution, you shade the other side. Okay, so the red one, where was that? That one we also shaded above. Okay, so the red one we also shaded above, right? But we only care about the area where both shading occurs, so let me neaten this all up. All right, and so we care about not what we wanted here. I have to change my pen. Here's the green pen again. So we shaded above the red, above the blue, and here are our solutions for this system of inequalities. All right, so let's practice a little bit more. The top one, oh, they're both in standard form. Okay, but look at the top one. The top one's got y by itself. So I might just change that into slope intercept. So what would I do? I'd subtract 2x from both sides and get y is less than, you just leave that symbol the way it is, -2x minus 8, right? And then I don't have to find the intercepts of that one. I can just graph it. Now, if you like the method of finding intercepts, then do it. So y is less than -2x minus 8. So y-intercept 0, -8. Slope -2, down 2 over 1. So I'm going to have to do some backwards ones here. But the big advantage of slope-intercept for this is that you don't have to check 0, 0, right? We're going to be shading below the line here. So there's the dashed line for the top one. Arrows on the end of your lines always. Now the bottom one, I'm just going to find the intercepts of this one. So the y-intercept where x equals 0. Divide both sides by 5. Y equals 2, so 0, 2 is the y-intercept. X-intercept where y equals 0. I'm just going to put the -1 in there to remind me. Divide both sides by -1. x equals negative 10. So negative 10, 0 is our x-intercept way over here. And it's a solid line. Once again, it's in standard form. It doesn't have y by itself, right? In slope-intercept, right, we're looking for the y's that are lower than the line. That's what that means. But here, you don't have y by itself, so you have to check 0, 0. So we're going to put 0, 0 in the blue one. So 5 times 0 minus 0 is greater than or equal to 10. Is 0 greater than or equal to 10? That would be no. So then we're going to be shading above the line. So the blue one, we're shading above the line. The red one, we were shading below the line, right? Oops, I was trying to do that in red. Right, below the line, and there's only a very small overlapping area this time. And, right, it's this area right in here. That's below the red line and above the blue line. Is negative 8, 1 a solution? All right, so negative 8, 1, this is a perfect one, is right there, right? It seems like a yes, right? If I did my graph accurately, but let's double check it, right? So how do you double check that? It has to make both equations true. So there, x is negative 8, y is 1. So the top equation would be 1 plus 2 times negative 8 is less than negative 8. So 2 times negative 8 is negative 16, plus 1 is negative 8. Is negative 15 less than negative 8? Yes. Then we'll do the blue one, right? So 5, I'm doing the bottom equation. 5 times the y is 1 minus x minus negative 8 is greater than or equal to 10. So is 5 minus negative 8 is plus negative 8. 5 plus 8, which is 13, greater than positive 10? Yes. And so that is a yes. It is a yes for both inequalities. Two ways to check. Right? If you're close to a line, you want to do this, right? But because you have to be sure your graph is right if you're going to use the graphing method. All right, is negative 8, negative 1 a solution? Let me get this out of the way. Down here, clearly no by the graph, right? And what it looks like, it would have been a solution to the red one because it is below the red one, but it won't make the blue one, right? It's a no for the blue one, and let's just show that. So y is negative 1, 5 times, right, I'm putting it into the bottom equation, 5 times negative 1 minus negative 8 greater than or equal to 10. So 5 times negative 1 is negative 5, minus negative 8 is plus 8, greater than or equal to 10. Negative 5 plus 8 is 3. 3 greater than or equal to 10? No. That's supposed to be a 10. And then no. So two ways I've shown that this is not a solution to this system. All right. Now, when we had parallel linear functions, we would say no solution. That also can happen here, but something else can happen as well. So let's see that. So you'll see right away, hopefully, that both of these have the same slope, so they're parallel. So let's do the top one first. Let's do that one in reds to be consistent. So 0, 4 is our y-intercept. Slope is 1/2, right? So both of these have the same slope. And it's going to be dashed. So let's do that. So there's the top one, the bottom one, and notice we're going to shade below that one down here. Okay, now let's shade the bottom one. So the bottom one is 0, negative 3 is our y-intercept. Same exact slopes, should be parallel to the other one, but this time it's solid. Let's try to make these parallel. Okay, but here I'm supposed to shade above. So what's going on here? So what's going on here is that the solution is this space in between. It's not no solution. The solution is all of this wedge. It's not a wedge, but this space in between the two lines. Now, it could have been no solution. If they don't when they're parallel, there might not be an overlap. Like if I change these symbols so they go in opposite directions, then it would be no solution. So when you see that they're parallel, right, it may be no solution, but it also may be this. Let's practice. So y is less than 3x. So that one is got a 0, 0. Oops, I want to do it in red. 0, 0 y-intercept and slope of 3 over 1 of 3. If you're not understanding why this is slope of 3, you should go back to linear functions. And so then this is dashed. And we'd be shading below it. All right. For the bottom one, y-intercept is 0, negative 7. Slope is 1. So over 1. Let's get this red out of here. Slope is 1. Every intersection is good. And it's going to be solid. Like that. And we're shading above the blue and below the red. And this is similar to the one we just had in that we are going to be shading in between the two lines. So again, you can check whether a point is a solution without making the whole entire graph. Right? If you get any no's, you don't have to finish. You're done. So there's x, there's y. So 5, I'm putting it in the top. 5 plus negative 3 greater than 2. Is 2 greater than 2? No. And so we're done. What does that mean? It means it was on this dashed line, right? If I had had that symbol, it would have been a yes. So the top one is dashed and the point was on the dashed line. It's not a solution. Let's try this one. So we're putting it back into the top. 3 plus 0 greater than 2. 3 is greater than 2. So it's a solution for the top one. Let's see the bottom one. Negative 3 times 3 plus 0 less than or equal to negative 6. Negative 3 times 3 is negative 9 plus 0 is negative 9. Is negative 9 less than or equal to negative 6? Yes. This one is a solution. It's got two yeses. It's in the overlapping shaded area. All right, let's graph this one. Notice these have the same slope. So let's see what happens here. So the top one is at 0, 5, slope of 2. And you're shading above. Right, you're shading over here. Bottom one, slope of 0, negative 7, also slope of 2. It's dashed. But you're shading below. So what's the solution? There is no solution here because there's no overlapping shaded area. Good luck with your homework.